let us now use lesson 1 and lesson 2 to solve problems. We are going to start with question 1. In question 1, they say consider the arithmetic sequence. So we are already told that this is an arithmetic sequence. So our sequence is defined by the terms 2, 4, 6, and they say it goes on like that. Remember, in lesson 1 we said a sequence of this sort is called an infinite sequence because these 3 dots means it continues until infinity. The word consider in the problem says that we should look at this sequence and try to see the properties of it. So because we're told that it's an arithmetic sequence, what I'll do is that I'll test to see if it has a common difference, because we know an arithmetic sequence has a common difference. This is to say that term 2 minus term 1 should be equal to term 3 minus term 2. So what I'm saying here is that if I take term 2, which is a 4, remember, term 2 is sitting here. If I were to write this at the top here, this is term 1, term 2, and this is term 3. Now I'm saying here term 2, which is a 4, subtract term 1, which is a 2. And I should get the same number even if I say term 3, which is a 6, minus term 2, which is a 2. So if I say 6 minus a 2, both these two operations, they actually give me a number 2, because 4 minus 2 is a 2, and 6 minus 2 is also a 2. And we can see in this sequence that our first term T1 is equals to A. Remember, we defined the first term to be A, and in this case is indeed given as a 2. Now we have considered the sequence, we are ready to answer questions. Question 1 says determine the general term of the sequence. So this means we are looking for the nth term of the sequence. We're going to say 1.1. Because this is an arithmetic sequence, it means it is defined by the formula Tn is equals to A plus n minus 1 times a d. But our A is the first term, T1, and we're saying it's a 2. I'm going to substitute a 2 there. Then I'm adding here an n minus 1, and our common difference, indeed, we said it's a 2 here. Now, to simplify this, I would have a 2 plus, remember here I'm going to use the distributive law, where we say 2 times an n, it gives me a 2n, and 2 times negative 1, that should give me a negative 2. This would simplify to a formula that is given by Tn is equals to this, and this gives me a 0. 2 minus 2 is a 0, and then I'm only left with 2n. Now this is my nth term, is the general formula they are looking for. The question is marked out of 3, so that means we need to spend 3 minutes. They'll give you a mark for the formula, which is in the formula sheet. They'll give you a mark for your simplification and a mark for the correct final answer. Going to 1.2, they say here, calculate the 15th and the 45th terms of the sequence. I'm going to start by looking at the 15th term, because we're looking for the 15th term and the 45th term. So to find this, I can use my general formula to say Tn is defined by 2n. And we are saying here that we're looking for T15. In other words, our n is equals to 15. The n is equals to 15. Now, I'm putting this 15 here at the bottom. So that now I'm going to have a 2. Where I see an n, I put a 15, right? Because the n is a 15. And we all know that twice 15 should be 30. There is another way of doing this question, and this other method is motivated by what we studied in lesson 2 actually. A very important and useful way of solving this, and it's going to be required also for the exams. I can come and say the 15th term of any arithmetic sequence is defined by a plus the 14 times d, right? We discussed this to say here on the d we're going to have one less the number of terms. We talked about that a lot in our lesson 2 when we're defining an arithmetic sequence. Now at this stage I know that the 2 is the a here, because remember a is the first term and is defined by the 2. So that now I'm going to have plus the 14, and we said the common difference also is a 2, right? We define that here as a 2, and this would simplify to a number of here I have a 28 plus a 2, it should give me a 30. And these two methods will give you the same answer. Now this question is marked out of 6, so it means finding the first part, the 15, should give you a 3, and also this should give you a 3. This is to say that they will mark you this substitution and final answer. They will mark you this substitution and final answer as well. So any of these two methods will give you 3 marks. The other part of the question is finding the 45 term, which is also, if we take the general formula that we calculated in question 1.1, we should be able to see that we're doing the same thing. This will be T45, so that I have a 2 times the 45, because in this case we are saying that n is actually equals to 45. So where I see n, I put the 45. Now here I'm going to have 2 times 45, that's a 90. It should give me a 90. Or you can still use the same method to say T45 will always in an arithmetic sequence be given by a plus 44 times a d. So that now the first term is a, and 44 times 2 was our common difference. If I multiply 44 and a 2, I should get 88. 88 plus 2, that should be a 90. And again, both these two methods give me the same answer. Very important to be familiar to use this method. Sometimes it becomes useful in some of the exam questions that will come across. Again, our 6 marks will be given from the fact that each method here will give you a 3 mark. Each method here will give us 3 marks, and the 3 from this one, 3 from this one will give you the total of that 6. 1.3, the question says to us that which term of the sequence is equals to 70. So what we're saying here is that if we have a term in this sequence and that term is equals to 70, right? What is n, right? Which term is that? What is the number of terms? Remember we said n represents the number of terms. It's the one that helps us to know the position of the terms in the sequence. So we want to know that if our term is 70, at what position is it sitting at? If we count the terms, where is it sitting at? Well, this is very easy to do because we're going to take our nth term, which is given by 2n, right? Tn is equals to 2n, and we are saying here that the Tn is actually a 70, so that now I have a 70 is equals to 2 times n. Now at this stage I'm going to divide by 2, and this 2 and this 2 would cancel, and I'm only left with an n. Now this side I have a 70 divided by a 2, so this means that I'm going to have n is equals to 70 divided by 2 should be 35. So this means at the position 35, right? When we get to 35 here, if we have T35, the 35 term, we're going to get a term that is 70. And very important to also highlight this point. n, remember, has to be an element of natural numbers. N has to be an element of natural numbers. You can't get n to be defined by fractions or decimals or even negative numbers, because it only tells us the position of the terms in a sequence. Where are those? It's like we're counting the terms from term 1, term 2, term 3, and so forth.